Hi everyone, welcome to Statistics Bios on YouTube channel. I am Mohan Aknari. If you like our videos, please click the subscription button and support to me. Join to our YouTube channel membership. Let's go to the video. Now we will discuss the topic for the two-factor ANOVA in without replications. This is the data format for the two-factor ANOVA with replications. We take the 11 experiment without replications. The E1, E0 is one of the experiment and the E10 is a final experiments. Okay, the next one for the we take the data and the shoot height and the root height. Okay, now the data format analyzed for the two-factor ANOVA for without replications. Okay, the go to the data menu. Okay, the see the data analysis tool. If you not see the data analysis in the data menu, go to the how to active this the tool. So go to the file menu and go to the option menu. To open the new tab for the Excel options. Then go to the add-ons. Go to the manage, click the add-on Excel, click the go button. The add-on tools open the new tab. Click the checkbox, the analytic tool pick, then click the OK button, the active the tool. Okay, now the click the data analysis tool, the open the new tab for the data analysis. Okay, now select for the ANOVA two-factor without replications. Okay, selected, then click the OK button. The open the new tab for the ANOVA two-factor without replications. The select for the input range. Okay, the select the cell, the title with the data. Okay, selected. The next one for the click the label checkbox, then alpha value 0.05. If you edited for our significant value, because alpha value 0.01 or the 0.001. Okay, now the standard value check to the 0.05. The next one for the output options. This is for the output option. The select the same sheet the particular cell in the output result. The two-factor ANOVA without replications. The next one for the new worksheet. The new worksheet open the new sheet, the output result. The next one for the open the new workbook, the open the new software in the output of the two-factor ANOVA without replications. So now we selected the output range for the same sheet. Okay, they select the cell, then click the OK button. Okay, selected cell, then click the OK button. The output result is ready to the same sheet in the two-factor ANOVA without replications. Okay, then now the first one table for the summary table. The next one is the important table for the ANOVA table. Okay, we now discuss the summary table. The 11 experiments and the shoot height and the root height. There will 11 experiments and the count, the title for the sum value, average value and the variation value. The highest the variation value present in the E2 experiment 2093.045. The lowest value present in the experiments, okay, the E3 312.5. okay, the E0 the total count for the value the 2 and the sum of value 70.7, the average value 35.35 and the variation value 886/205. Okay, the next one for the root height. The root height total count the value for 11, the 11 experiments and the sum of value for 723.8. The next one for the average value 65.58. The variation value 387.508. Next one for the root height. The root height count for the 11 experiments and the sum value 170.6. The next one for the variation value 15.50909. The next one variation value in the 9.130909. Okay, the next one the important table for this data and the ANOVA table. Okay, the first one for the source of variations, the next one for SS in the sum of square value, DF for the degrees of freedom, the MS for the mean square value, F for the table value, the P value is significant value and the F critical value. The first one for the row value, the sum of square value for the row value 1998.656. The degrees of freedom, the value in the row 10. The mean square value in the row 199.8565. The F value is row value 1.015621. The P value for the row value 0.490464. The statistically significant. Okay, the next one for the critical value. The critical value 2.978237. Okay, the next one for the column. The column ANOVA value for the sum of square value 13,910.47. The degrees of freedom 1. The mean square value 13,910.47 for the same sum of square value. Okay, the F value for the variable is 70.6895.6. The next one for the important the ANOVA value for the significant in the column, the 7.6, the e power to the minus 6. Okay, now the critical value for the row column, the 4.964603. The next one for the error in the source of some variations. Okay, the sum of square value 1967.825. The degrees of freedom 10. The mean square value 196.78.25. The total value of sum of square, the 17,876.85. The degrees of freedom the 11. Okay, now the discuss for the important the significant value. The standard significant value p less than 0.0, the table value. Now over the row of the significant value 0.49. So the less than value for the significant value in our row value, so statistically significant. The next one for the column p value, they mentioned to the scientific value. This value converted, so the e power to the minus 6, so mentioned to this 0.6, the before 10 you mentioned to the dot. Okay, 0.050, totally the 60, 2 3 4 5, and the value for the 7.6 mentioned to the 76. Okay, this is for the next one, the significant, the statistically and highly significant in the ANOVA table in the column range. This is value for the high 0.00, so this is a highly significant. And the next one for the 0.49 is the lowest significant percent in the row value. This is for the table output in the two-factor ANOVA without replications. Okay, thank you for watching this video. If you any doubt, ask me the comment in the leave the comment box. I will help you. Thank you for watching this video. If you any doubt, ask the question. Thank you.